Okay, that's what we're dealing with for this project, transverse waves. And this is the waves that we can see in the water. This is the waves that we can see in other mediums. This is also a wave, a light wave. Okay, so when we see any waves that look like this is a transverse wave. And we know that this is one wavelength, right? Mr. A went over that. You know the amplitude, and we know that the crests and troughs, we know all those words, right? Okay, so that's pretty easy. Now, in addition to this, there's another type of wave that I just want you to know the name of, but we don't really need to talk about too much. Longitudinal wave. You ever heard of a longitudinal wave? Anybody ever seen a slinky? If you take a slinky and you pull it back and you let go, it like stretches and goes. That's a longitudinal wave. So I'm going to draw it like this. And then you put some closer together, and that's the wave. And then it stretches back out, and then it goes closer together. So these are called rare fractions, and you don't need to know the vocabulary for it, but I just wanted to show you that there are two different types of waves. These ones, sound waves. Sound waves are the biggest example of this. Slinkies also can show this. If you stretch the slinky and let go, it'll go. I wish I had my slinky with me. I forgot it.
You know, I have one too, but Ayla was playing with it, and then I forgot about it.
Yeah. So that's the first thing we understand. Okay? Number two, what happens when the amplitude gets bigger? What does that represent? He talked about it, but do you remember? So what does that mean in terms of strength or? So it's got more energy. So anytime the amplitude gets bigger, it's got more energy. Now, what happens when two waves collide? Well, let's draw a wave like this. Let's draw a wave like this. And these two waves are going to hit each other. What do you think is going to happen?
Fight.
They're going to fight.
Yeah.
Is it going to get bigger, smaller, stay the same size? What's going to happen? It's going to get bigger because they're both going up. So when they hit each other, this thing is going to get even bigger. And that's called constructive interference. Okay? This is the principle of superposition, and that just means that they add up. Okay? But constructive interference is what this is. What do you think is going to happen if we do this?
Cancel.
They're going to cancel if they're the same size.
Tornado.
What? Yeah.
And so that's going to be called destructive interference. So constructive interference, it gets bigger. Destructive interference, it gets smaller. Basically what happens is the energy from the waves add up to get bigger. The energy cancels out to get smaller. Okay? That's really basic. It's really quite easy to do. So you have a practice today that you're actually going to be doing this. And there's like little squares, and it tells you a time and how fast it's going, and you're going to draw it every second. Okay, that's your practice for physics. Yes?
So does which way like the wave is going, does that not matter?
It does matter. They're both going towards each other. If they're going away from each other,
like, what if they're both like going the same way but one's faster? And then catches up to it.
If it catches up to it, then it'll stay. They'll stay two separate waves. And then when it hits it, it'll get bigger, and then it'll keep going, or it'll
So
get
like,
smaller.
which way is that top wave going to end up going?
This one? Okay, so what's going to happen is that they're going to come together and make the big one, and then they're going to both keep going the other way.
Huh?
So then they get small again?
So yeah. So let me draw that. You ready?
Yeah.
Okay. So this guy, if I drew the whole thing, this is going like this. This is going like this. When they combine, it goes like that. Gets double the size. It gets bigger. Okay. And then when they're done, this guy's still going this way. This guy's still going this way. Got it? So they just keep going forever and ever until something stops it. So that's our next thing. They make a big new one, and then they keep going their separate ways. Now, they both get big.
Does one of them
It becomes a big giant one together.
So technically, doesn't it become two big giant ones?
No, just one.
So how do they both keep going?
And then they get smaller again. There's a video I can show you. I posted it online actually because I knew that you were going to ask this question. All right, so that's the first thing. All right, next thing. What happens if it hits? So like, if it's on a string, let's say, and this thing is moving like this, if it gets to the end of the string, what's going to happen? So if it's an open-ended string, yeah, it's going to just fall off. It's going to disappear. Or it's going to keep going if there's more string. If there's a wall here or something holding the string, it's going to bounce back. But it's not going to bounce back going up. It's going to actually flip and reflect down. So this wave, as it goes towards here, when it hits this, it's going to come back, same size, going that way. Okay? And that's called a reflection. So we had constructive interference, destructive interference, where it cancels out or gets smaller. And it can get smaller, it doesn't have to completely cancel out. And then here is reflection. Okay? Everybody understand so far? Julia, you remember this from my class forever ago? It's from freshman year? It's a long time ago. Alright, so we go with this. There's one more concept that actually I believe Carrie is an expert on. What did you do your thing on? The Doppler effect. So, the last thing that we have to talk about is the Doppler effect, okay? And it's in your rubric as, I believe, extra points if you're in a plane or if you're in a boat that's moving as you're taking your data. What's going to happen? So basically, think about this. You're standing here on the side of the road, and how many people have heard like a siren go by?
Never in my
You heard
life.
that?
Nope.
Okay.
Ever.
Do you know that the sirens are exactly the same sound? They don't project different sound, but it sounds like they do, don't they? Yeah. So it's the same frequency the whole entire time, but because they're moving towards you, something strange happens and it sounds like a different frequency. And then when it drives away, it sounds like an even different sound. So why? The Doppler effect. What? So as it's moving towards you, I'm going to try to draw a car here. I suck at drawing, so just bear with me here.
She's beautiful. Ooh,
Yeah, there we go. There we go.
I love her.
Big car, okay. And we're going to put a little siren on there. Okay? So as it gets closer to you, what happens is, because it's moving, the waves get closer and closer and closer to you. And it gets closer together as you get towards it. Because the object is speeding up towards it, so the waves have to get closer together. So that's why you hear different sound. What do you think happens when you go past it? So the waves start to get further and further and further apart. Okay?
Beautiful.
So that is the idea of the Doppler effect. Yes, ma'am.
So they're longitudinal waves?
What I just drew it as longitudinal because that was sound, but it works the same way for transverse. So the frequency gets less when you're going towards it, and the frequency gets further away as you go away from it. And that kind of makes sense, right? So as you're moving, you're moving towards something, the things have to get closer together, and as you move away from it, it has to get further apart. This is the same reason why when we look into the sky, we see some things as red and some things as blue. Not like the actual sky, but like stars. If the stars are red, then that's a lower frequency and it's moving towards you. And if the star is blue, it's moving away from you. And there's different shades in between. But that's why, because the frequency gets smaller or bigger based on the movement. Yes?
And don't stars like evolve because like they're so far away and kind of the I don't know, like the light kind of like flickers in your eyes almost.
Sort of.
Like, yeah.
That's a very simple way to say it, but yes, kind of. So does everybody understand Doppler effect? Okay. So that's all the notes. That's it for physics. You learned everything else with Mr. A. That's the only thing that we didn't have covered yet. There is a practice that I linked on the agenda. It's your benchmark for physics. It has you drawing individual waves coming together and having constructive or destructive interference. Okay? Just like you're going to do for your project. What it wants you to do, it wants you to use 3 different colors. Pick a color for A, a color for B, and a color for them coming together. And draw each one every time in that same color. So that way you can really see what's going on. It makes sense. Okay?
We do have colored pencils and crayons if needed.
Everybody got it? Anybody have any questions about this stuff? All right. Good luck.